Principal Component Analysis Introduction. In this video, I will talk about what is principal component analysis and how we use mathematical to solve the PCA in general. Firstly, main introduction. The main purpose for PCA is to reduce the dimension of datasets and increase the interpretation by minimizing the information loss. It works best for small dataset and it is unsupervised learning. Why should we reduce dimensions? For example, when we try to categorize different dogs and with the heights and weights as the features, then we think the height and weight are good enough. However, sometimes when the height and weight are efficient to do the classification, the data features include too many different information. Other than height and weight, there are length of tail, shape of teeth, and so on, even include the color of eyes. For this simple example, we can easily figure out which of the features is useless. However, in real project, it is not a good idea to remove the features directly without any analysis. So what should we do? We should use the PCA to analyze how to reduce the different dimensions or more dimensions into lower dimensions dataset. How PCA works. PCA would use some mathematical tricks to reduce the number of features or the number of dimensions. For example, we have a data point in the current coordinate system, and we represent this data point as 10, 12.5. And later on, we use the mathematical to find a new coordinate system. And after we find this system, we project this data point on the new coordinate system. And the data points would be represented as 12, 2 on this new coordinate system. So if we just want to reduce the dimension by remove one of the previous coordinate system, we're gonna lose about 50% of information. However, in the new coordinate system, if we want to reduce the dimension by removing the second value of the coordinate system, we may just lose 2.2 over 14 information. It is much smaller than before. And the PCA used some mathematical tricks to reduce the number of features by the minimizing the information loss. So when we use the PCA calls the 12 and 2 as PC score. The PC score 1 for this data point is 12, and the PC score 2 for this data point is 2. Besides that, 12 is the length of the projected line on this new direction. 2, and this line has the direction to be projected. 2 is the length after we projected this data point on the second line direction. How PCA works when there are more than one data points. For example, currently our dataset looks like that. And the PCA wants to find the maximum variance direction to keep more information. Intuitively, we can find this direction, so it's gonna look like that. After we find this new direction, we want to project all the data points on this new direction to achieve this length. The length is what we call PC1 for this specific data point. And each data point should have a value of PC1. The second step is to find the orthogonal variance direction, the green line. The green line has the 90 degree along with the red line. And after we find this direction, we want to project all the data points on this new line as well to find the length as what we call PC2. All data points should have a value of PC2 as well. After we find the line 1 and line 2, we actually find the new coordinate system, and each data point should have a new representation of under the new coordinate system. When the sum of PC1 is way larger than sum of PC2, then we can remove the PC2. Then PC2 removal will result with the minimum information loss. As PC1 can represent majority of information, we will just use PC1 to do the analysis in next step. So this is generally how the PCA work and how to use the mathematical idea to solve the PCA in general.